Okay, the plan is simple. Here's an ultrasonic rangefinder on a servo. Here's an cheap, well, it's still good, LCD screen, TFT LCD. This is going to go from 0 to 180 degrees, get the positions, and map it on the screen. And we'll use Arduino standard library and a few extra libraries. Okay, so I've already written a bit. This is just this didn't take long to make, so this will be improved in the future. I'll start a new file. Oh, here's a preview of what I've done, but I'll go through it from the beginning. So file new. So as I said, there's a servo, step motor, and a TFT screen. LCD TFT. For now, we'll write the program that gets the data, and then afterwards we'll display it on the screen, which is the simplest way of doing it. So I don't think I'm going to type it step by step. I'll just copy and paste and just show what I did. So I'm not going to write my own PWM function, so I'll just use the servo library. The ultrasonic sensor, I wrote that myself, my own functions, but then I found this new ping library, which is much better, and that's all that's needed for now. Later on more will be added for the LCD. So also I'll define some pins. I could do define as well, I just made them constants, and that's it. The servo pin, trigger pin, echo pin. So now we make our servo object, because servo is a class, and yes, that's it. So we have our servo class. We'll make our ultrasonic class or sonar object from the new ping class, and the three parameters the class takes is the trigger pin, then the echo pin, and then the max range it can detect. Yeah, this is the max range in centimeters it can detect, if I am not mistaken. And that's all we need. Now I'm going to make another class which is going to take the servo and sonar objects and use them to map the data from each point of the servo from 0 to 180. So it'll be a class, and I call it range mapper. It's probably a better name for it. And that's it. So I'll have some publics, privates. Not really necessary, but this is a more computer science way of doing things. I'm not a computer scientist, by the way. So we might need to use some private variables. I did initially, before using the sonar, the new ping class, I would store the trigger pin, echo pin as a private variable, and then I'd initialize them using the constructor. So make the constructor. Since we have our trigger pin and echo pin sorted out, we don't need this in the constructor. We could do our servo, but no, this is in the. I could pass these. I don't really think we need anything in the constructor yet. So I make a range so we can sweep through a range, or we'll make a point first. So get point, mapper.point, get point, map point. It's not really mapping if it's a point, but I tried to put map in front of all the functions inside to get consistency. And then we'll choose, we only need the unsigned car because it's from 0 to 180. So position. Guess I can't use that. Capital P. I don't really like using capital P, but I'll just do pos. So we have position. So the way this works, I'm going to do everything in centimeters. On duration, I'm not doing a tutorial on it. I'm just showing you how I've done this, and actually I'm actually kind of optimizing it a bit from my previous code while at the same time. So a bit of improvisation here. So we shall return, and I like to use the iterations, the median. I have to look at the function list, the description about these, what it is. Anyway, it takes an average of a few samples. So your first reading might be off, something causes it to be off, so it takes several readings and then average them. And I think it's the median, I don't think it's the mode, it might be the mode, but I think it's the median average. So just from here we'll return, so the function for that, I'll actually copy and paste it instead. Which should be in one of these. I got it off screen. I've got 3 separate screens here, so you can't see what I'm doing here. But it's okay, this is the only screen that needs to be seen. Because I've just practiced this today. Okay, here's the other one. That's what I wanted to look for. So I'm still getting familiar with this. So just return the value from here. So this is the median that takes the samples, but this returns it in microseconds. There might be one that does centimeters per sample. I don't think there is. I didn't really look properly, so if there is, just use that one function instead. I take the milliseconds, microseconds, and then convert it to centimeters. Pass it to this function. And I think, I haven't tried it, maybe you can, no, because you're not creating it, I was going to pass it by reference, but never mind. Forget I said anything about that. So yes, this will return our point. Obviously we need to get samples. I'll make this an int if for some reason you want to go above 255 samples. So it will be very slow, but well, not too slow. But if we do it for a whole range, just for one point, it's not going to be slow. But if you do it for the whole range, it will be really slow. It might be a good idea to a lot of samples if you want to just get an accurate mapping of the room the first time. Make sure every point is correct. But if you're moving and then scanning and moving and scanning, you want to do less samples. I found even 2 to 4 can be very good from my experience. So obviously since we're returning something now, I've got this wrong, it's an integer. And you could store it in a private variable and then, but I'm not going to complicate it. But the next one will use a private variable. So here's the point. Now we want to, actually I'll leave it here. Now this one's not going to return the value, we'll do a separate function for that. So we'll map a range instead. So we'll have unsigned samples. So we'll have a low value, a high value, and the number of samples. I think that should be okay. Low, high samples. Yes, that's fine. Now we're going to store this in an array, so let's make a private variable. Since this returns integers, we could cast it into unsigned, but I'll just make a array map. Since it's private, map data, and since this goes from 0 to 180. Yeah, 0 to 179. Okay, we'll do 180. I guess in the constructor we could clear. Actually, we'll make a clear function to clear the map data, and then in the constructor we'll clear it at the beginning. It's not really necessary. I think it defaults to 0, all the numbers in the array, but it's probably good to do that. So we'll just do a clear, not a clear. Oh no, we'll do a clear range. If you want to clear a section, we want to leave a section, so you could inverse it as well. That's possible. Okay. See, I didn't do this on the other one, so clear section, clear range, clear data, clear map. Yes, that's probably good. So unsigned character, sorry. I'll just copy and paste this, and then we'll use 01. We'll call it inverse. So I'll probably just quickly explain this, it's not too complicated to. So I'll draw the array this way since it's easier. So you pick two sections, you can pick the start or to the end, that'll clear the whole thing. Or you can pick a section, not straight lines but whatever, to clear. Or we'll pick a section to clear, here to here. And if you choose the inverse, it will keep, instead it will keep this, and then it will just clear this part instead. So I haven't done this, just I got, it shouldn't be too hard to figure out. So I guess an if and else would be the best. Okay, so firstly we'll make a variable. I won't declare it in the for loop just yet. For I equals 0, I is less than low. Thinking how to do this. The most efficient. I know how to do it in an inefficient way, but I'm just thinking of the most efficient way of doing this. Okay, let me just do this way for now. For I equals I is less than or. Do we want to 0 index it or 1 index it? We'll do 0 index, so 180. I mean, not in here, but up here. So you say the first element, but then I do less than or equal to. Let's just leave that for now. Yes, okay, I plus plus. And then for the last one, I guess we're doing it if and else, I guess. Or I could do a case, it'd probably be slightly faster, but yeah, I guess I do it this way. I equals low I is less than or equal. I'll see how it goes. I'm not really thinking too much. Yeah, okay. So we'll do a switching case because it's only two. Switch. So this should clear. So normal clear or inverted clear. So this would be the inverted clear. So that would be case 0, that would be case 1, or case true. Yes, that should work. Oh, delete isn't working, now it is. Come on, delete, don't let me down. Case 0. Break from the case. Inverted is true. If it's true, do the ends. Okay. So that should be a nice clear. And then in our constructor, we'll just call the clear map function, and we'll just go from 0 to 179, and we won't invert it, we'll do the whole thing. But if we do the inverse, it won't clear anything because we're already at both ends, so to try to go past that, it can't. It won't even try because it won't be in the right range for the for loop. Alright, so clear data, and then we can call, this can be called anytime in the main function, loop function. Okay, that cleared the map. Now we'll do our range. What am I doing? See, I don't trust the tabs in this, but I should. Okay. Map our range. So, in our setup, should we do it in when we call? Because we're not going to use the servo until we use the map class. So, servo.attach to our servo pin. guess we'll leave this out. I don't want to make this better. Okay, so we'll call the attach function, clear our map. Probably, I think I did this in the other one. Yes. No, we don't have to set our trigger pin and necker pin high or low now because I'm using the new ping library now. So yeah, we'll just do this. So firstly, just servo.write. Go to our low value first, just to get things ready. It might be on the other side, so just do a delay of 200. Could be alright. I'll play it safe with 400 milliseconds. So we could use the low, iterate through that, but I'll get, well, we need save space. Low, less than high. When you're designing for microcontrollers, reuse what you can, I guess. This should be fine. If it's not, I'll change it afterwards. And then we'll write to our position. So I did this here to let it go to the beginning and then wait a bit for it to actually turn. But now here, I'll do I've actually tested it with this library. You don't really need a delay at all if you're going through iterations. Like, you could do an if iterations equals 1, put delay, otherwise don't. But I think I'm always going to do more than one sample. So I'll write it anyway and I'll comment it out. If, or samples, not iteration, if samples is equal to 1, delay 10, that might be a bit slow, but it's probably best to do that. You could probably change it if you want, but I'm not going to use this for now, so I'll just comment it out. So we write our position, now we get our data and store it into our array. We get the distance and store it into the array, sorry. So I'll copy this. So map data, since I'm using low to read it, so we'll call it low, so that's the exact position in the array. It's equal to the conversion in centimeters. Since this is going to be for a robot, fairly big robot, centimeter precision is fine. I'm not going to use millimeter precision. If you want to use millimeter precision, again, I'm not sure if it has one. You will just have to convert the microseconds into centimeters yourself. For distance, you times the speed of sound by the time in seconds. So that's how you calculate it. That's all detail I'm going to go into. So, and to really get this out of the way, because I'll make this as small as possible, I'm just going to put this all in one line. And just get this out of the way, don't need it. Guess if it's on one line, I can do this. Yes, okay. So write a servo position, put it on the map, and that should be fine. That should get just thinking if I missed anything, and no I haven't. So map our range, clear the map, get a point on the map. So now we'll write a function to get a getter function, I guess. Now previously I had an array in the loop function and I passed that array onto here. And I haven't tested what way is faster. Maybe we can just always use this as the reference instead of storing it in a new array to save in space. So I will make the see, I'm looking at my other code just to see how I did it then, and already this is looking a bit better. So I should probably just think of this instead of looking at the other one. So I think I will make the get data function first. So void map range, map point, map data, data to get data, get map data, get the whole map. Could do a range as well. I think I will do a range on this one as well. Get data range. Yeah, I think that's the best way of doing this. So we'll have the low and the high. Should we do? I think I do an inverse as well. Why not? I think I'm making this a bit too fancy now, but oh, we'll see. Let's check if we have if there's any errors, so I can check how much memory this uses already. Save it. I'll save it as I guess map test v1 version 1. Oh, expected before yes, here we go. Semicolon. Yep, that's it. This is all good. So get data range. So we'll pass. I made it an int, so we'll do a int array. So we'll pass our array through, and this is by reference anyway. So we're not creating a new array and then destroying it. We're just getting the array we create in our main function and putting the map data straight into it. So I guess the best way of doing it is just to copy and paste this. I'll change that to an unsigned character as well. Save everything we can. So yeah, very simple. Set forward, it's the other way around. Array. I usually like to put spaces in between not there, between this and this, but I'm just saving time. So array I equals map data I, not minus I. So this is grabbing this section, and these are grabbing the sides of the section, the ends of the section, the two ends, the inverse of the section. Which you might need it, but it's there anyway. It's good to have. And I didn't really check how much this is using. Okay, not much so far. But there will be quite a lot used when we create the actual map to save the whole room the robot is in. I've suddenly decided this is going to be a robot. Not suddenly, but... Okay, not too bad. So... We're at a point, we have our get data, clear it, see what I did in my other one. That point. Could do this one. So it could multitask, it could map at the same time, other things going on. But for now, I'm not going to do that. I used a millis function to get time, and then I would check the time, and if like it reached a certain interval, then it would take a point, store it in map data, take a point, store it in map data, take a point, store it in map data. I'll just show the function from here quickly. Very simple. This function here. So get the current time. Store rotation. I made that rotate a right variable. Oh no, the position. Sorry, rotation is just what way it's going. I made that private as well. So it knows where it was rotating, if it was rotating to right or left. So it'll go right, and it'll go left, and it'll go right. Oh, clockwise, counterclockwise. And it will store the position as well. So you can pause that, read that. I'll put the private in as well. That's about it. But this is looking not as nice as what's going on over here. Even though this is going to, you scroll up and down, yeah. I guess doing it in Visual Studio is nicer, but oh well, that's another time. I shouldn't have opened that. Close. Okay, so I think everything is done. All the basic functions. We could get another, just get data point instead. So I think I put it here. I could make this into a separate C file and make a header file for this, which will be done eventually. But for now, we're just writing it in the main program. So this will be int get data point. So just unsigned character position. That's it. Return map data position. Very simple. Nothing to it. Right. And now this creates an interesting situation. No, it doesn't. I was going to say you could just put the point in there, but you could just set the range to... Yeah, this is fine. This is okay for now. I think I've got to test this as well. So I think this data point gets the data from map range, not to do with map point. This just instantly returns value. This data point is getting a value from map data. So that's okay. So clear map, map range. Yeah, I think that's it for now. Now we're going to draw it to the LCD. So this is obviously going to vary from which LCD that's going to be used. For me, I'm using the ST7735 LCD. It's 128 horizontally, 160 vertically. Funny thing is, it says it's 120, it's printed, so there's a typo there. So that, it messed up, not too long, but I was wondering what the actual resolution was of this when I was trying to display it. So these are the two libraries I need to use, and I'm going to use the SPI library as well. I haven't actually tested without this, but it's obviously connecting through SPI. We're not going through the separate pins. When we call our TFT, so I'll just copy this. So this was literally taken off an example, so I didn't make this at all. We call our TFT a chip select. DC and reset. And because of just the way I'm connecting it to the Arduino, this is going to look a bit weird how I'm doing this. But I'm also connecting my backlight, ground and VCC. I guess that could be justified. You want to save power, so you turn the backlight off through a digital pin. I'm also connecting my power input and output through the digital pins as well, just because I've already got the servo and the ultrasonic sensor connected. Got the servo connected to the 5 volts and ultrasonic to the V in. Is it V in? Yes, the V in pin, so that's the two power sources. I could connect to the ICSP pins, but I'm not going to do that. So this is important, connect these three. Oh, chip select's not important, but connect the serial clock and the master out slave in to the correct pins. If you're on the Mega, you'll have to use 53, 54, 51, 52, one of those. So, because those are the specialized SPI outputs on the Atmel microcontroller. I think there's libraries where you can probably use any pins, because you could software emulate it. But this is what I chose. This is all temporary, and you notice there's a these are constant, these are defines. I'll just make them all defines. I guess I'll do that now. It's not a big deal. I just wanted to save a bit of time. Oh, come on, if I can do this properly. Just to make it consistent, a bit more consistent. Oh, then I got rid of it. Oh. Alright, maybe this wasn't the best idea, but it's done. It's done, it's done. Yep, 5. So this all defined. Guess before I'm gonna do the LCD, no, that's fine, that's okay. I'll define my screen width and height as well. This will vary, but hopefully the way I wrote it could be compatible for any resolution, because we're going to map the values. We're going to change the range of the values to accommodate any screen resolution, so we just change this to any number and it will automatically map it for us using the map function. So I'm using map for changing the scale of the values, and map to actually map the room, but it's okay. So I'll copy all this for now, then I'll delete what's not needed. So let's split this up into two. Because of the stupid way I'm doing this, because I'm using digital pins for my power and ground and backlight, I've set them all to outputs and then set to high. Ground is always low and the backlight has to be high since it's an anode, not the cathode. And then, as I said, I took the TFT from the example, so mine had the green tab, so this is the initialization. I don't know what number this is defined at, I haven't looked at the function for this yet, the library. So, you can read that. This is all I need. I'll leave the comment there still though. And I decided to leave the serial for if you want to just do some basic debugging. So that's okay, that's fine. So TFT is initialized, we got our map class, and now we're ready to start printing things on the screen. Almost, very close. I could make a... I like to do this for future, so in the future there will be a okay. Oh man, I think properly today, come on. So I'll have an exit variable or boolean. So once this goes out, we'll exit out of here, and then you can like do some final deconstruct your objects or do another task. But I like to do this. Could do false, could do 0. Yeah, it's up to you, but I'll do false for now. So again, I'll just copy this function. I'll choose the background color. Do a black just to initialize. I guess you could put this on the. I think on the setup it will be better. After starting serial port, I guess. Or maybe it doesn't matter. Not for now. So because of how I did this, I'm passing it through DeRay. I'm not getting a data point, so this is less inefficient for now. This one, think about it. You can even think about it, how to do this more efficiently. But for now, I'm just going to use it because I've done it now. So, should I do it in the while loop, or I'll do it outside for now. So stick to the best methods. Put all your variables at the very beginning. Older languages don't like that. So we'll have our data, we'll match it to the map data, which has 180. And actually, that gave me a good idea for the clear. Low, high, and inverse. So int will pass out array through instead. So we can use it to clear our data as well if we so wish to do. Yeah, this is probably a better way of doing it. So I'll clear the class later on. So in our clear function, we'll put map data through it. So create our object. I'm not sure if it's better to do it before or after. I'll do it before. Mapper. Range. Map. I'll just call it map. No, I can't. Maps. I'm not being very creative with my names today, so I'll just call it mapper1. There's not going to be more than one, so mapper1. Why not for now? Mapper1. So I didn't actually put any, so I'll leave it as that. Mapper1. And just for now, mapper dot clear data. Yeah, maybe I'm making this a bit more complicated than it needs to be. From 0 to 179, and inverse is false. So clear map, clear data is probably better. And this could be its own separate class to manage the arrays, but oh. So I'll do less than or equal to. Low. Do you want to? No, I don't want to clear that one. It has to match it then, doesn't it? Okay. The high. We could do high plus 1. Yeah. Okay, maybe this one. So clear our data, start loop. So, I could just pretty much copy and paste. No, I'm not going to copy and paste. So, mapper dot map range. I did call it map range. I'm looking at both at the same time, which is, again, I shouldn't be doing this. So we're going to go do the full range of the servo. There's our low and high. Two samples for now. I'll do 4. Why not? F1, the map range. And then do I want to, yes, I want to get the data mapper 1, not mapper. I'll change that in a second. Dot get data map data. Get data range. Data point, get data range. So we're going to pass through. So I could overload the function, so you could put no, don't do that. Okay, so from 0 to 179, and we're not going to do the inverse, obviously. There we go. And then we're going to have another loop, so I just want to make sure the screen is black here. I'm not really going deep with the explanations here, I realise this. But if you're good enough to follow along, you're definitely better than me, so you'll just know what I'm doing and you'll see the corrections in your head instantly. I'm doing, keep it consistent. I'm doing to point 178 and not 179 because I don't want to draw from the vertical. I want to draw between 2 points to get, I need a pencil. I want to draw between the 2 points to get the position of the objects in the room, whatever's in the way. That could be a box or a chair. A chair would be more like on the map, so a box, bad drawing, but you get what I'm saying. If you always start from the origin, it's going to be like this, your clear space. That doesn't look very nice. This looks a lot better, so you can actually see the clear space. And when you go from 0 to 178, I'm doing it between, I'm going to take the first and the second point all the way to the last point, so then when I get to position 178, I'll be using position 179 as well in the 178th iteration. So I could even do could put that in the I'm just copying what I did here, but I could put that in the class actually. But I'd want an LCD class, or no, I'll just put it in the map class actually. Yeah, I think that's the background line. See, this is just the beginning. It's only going to draw in the here's the LCD. I'm doing it horizontally. Split that in half. It's just going to show at the top, and then later on the plan is to make a box or a semicircle to contain it in. Have some data on the screen as well, and then you could even have a section reserved for like warning, collision, I'm going to put a compass on here as well, so it'll have a bearing. So it's going to be full of features, but for now I'm just going to keep it simple. So I am going to actually make another function in class, the map class. Clear data. So it's pretty arranged now. It's becoming a bit convoluted, I guess. So it's going to be void draw range, data range. Low, high, inverse. Okay, I didn't do this before, so this is going to be interesting how I'm going to do this the first time. Low, high, and inverse. Okay, let's try this. I got my other one as reference. Okay, so quick explanation again. You may not think it, but the data we are getting right now is actually could be considered in polar form. Brush, yeah. So we start from position 0. Well, since it's in polar form, position 0, 0, pi, or 90 degrees. Well, I've got a graphics tablet for this. My pen is somewhere, not too far. Okay, I'm just going to use the mouse for now. It's underneath something. I don't know what. So 0, 90. I mean, my mouse is resting on the graphics tab, though I just need the pen for it. There's a lot of wires. Not ideal. Okay, never mind. Oh, no, I unplugged my mouse. Is it working? Yeah, it's fine. Let me open this, check how long I've been recording. Okay. Nearly 1 hour. So, 180. So it's in polar form. We know the position. We can just use that as the position in the array for the degrees, and we have the magnitude. It's this high, this far, this far. And obviously, when we map it onto the screen, there's no. I don't know if there's a polar grid function. No, I mean no, there isn't. We're not using Matlab or something. Polar plane. So we're going to convert it to Cartesian coordinates, which is very simple. So here's our polar plane. We're at 45 degrees. We've got one there. We've got our magnitude, which is going to be distance, like 200 or 20 centimeters. Got 45 degrees. Okay, I really need to find this pen. This is not good with this mouse, and the sensitivity is a bit high. I'll decrease sensitivity. That's too. It's okay. So 20 centimeters, 45 degrees. To get the x, or the real part, and the y, the imaginary part, just do the magnitude, which is 20. So to get the x, 20 cos 45, which is the degrees, and that will be the position of the array, and that will be what's in the array because of the way it's set up. And same thing to get that will give you the x position, x equals, and then this is so bad, y is the same, 20, but then you'll use sine 45, and if you don't know the maths, because on a plane it's e to the I pi, and that equals cos plus I sine or j cos x or something like that. So we use cos and sine. Fortunately, there's no cosine degrees function like in Matlab or something else in sine degrees. So it's actually in radians. So we have degrees, so we've got to convert these degrees to radians and then put them in the functions, which is very simple. Just multiply your degrees by pi. So we've got our degrees, I call it I, because I call it I, multiply it by pi divided by 180, and then we convert it into the correct. Otherwise it will look very strange. You'll be going around the circle many times for your points, like 1 degrees, 2 degrees, 3, 4, 5, 6, 7. It'll just keep going around. It won't be a proper map, it will look something like this. Okay, the screen's getting too much. That's the end of the undos. Escape, don't need it. Don't think I need paint anymore, but I'll just get it ready. Okay, so should I copy and paste this, or should I do it? I'll do it bit by bit. Probably the best. So now we're actually going to draw to the screen in this function. I'll deal with the inverse later on. I'll just go from low to high. Oh no, I don't have to do that. I'll just copy this and build upon this. So we'll switch on the inverse. Don't need this. Wait, I'm really wondering how this is going to work now. Okay. Alright, whatever. I'll leave that for now. I'll just put it here for now. Okay, so this was about to be a tutorial, but now I'm kind of just, this is me thinking about how to do this. So, because we've got our for loops here. Let me think about this. Okay, firstly, if I'll just do a quick explanation. This screen is a low resolution screen, I'd call it. So, and as I'm putting it in the top half, this is 160 pixels, the full range. So 80 pixels here, and this is 128, so 64. And because I want it to be uniform, I'm going to start into the center point. The max range, the maximum length the line can be is only 32 pixels. So I've got to show, since we set it over here to 500 in our sonar object, we're ranging from 0 centimeters. It can't really do 0 centimeters very well. I think the range is 2 centimeters to 400. So actually I'm going to set this to 400 instead. I'm using the HC04. Let me see, I'm reading it right now. HCSR04. So when you look at the spec sheet, it says range 2 to 4 centimeters with a resolution of 3 millimeters. So in 32 pixels, so 32 of these, I have to show a range from 2 centimeters to 400. You could just do a division, plot your y and x, find the gradient of the curve, make that your function, or you just use the map function instead. But this is a very small range, So I think objects that this will really, you're not going to see the subtle differences. So probably we're going to display something on the screen that's only 1 meter away. Anything else doesn't matter yet until we get closer to it, then we'll be able to see it on the screen. So on our draw range function, low, high, inverse, we're going to do like an unsigned integer, because we're not going to do negative. I guess there's a few things other I can make unsigned, but it's okay. And we're going to do distance, and just to make it clear, it's in centimeters. So that's the absolute maximum distance it will show on the screen. So this will be the max distance it can show, how far it can see, the scale of this map, basically. And that should be everything. Okay, so this is going to be very inefficient now, unfortunately. I'll think of another way to make it. I'll think later how to do this, or maybe you'll think of a better way, which I'd love to see. Let me see if there's any problems. Clear map. I think I called it clear data, didn't I? Yeah. Do I need to create inside or out? Yeah, that's not a problem. Or maybe it is a problem. Yeah, that's not a problem for now. Bool exit equals false. False was not declared. Oh, false was not defined. Am I doing something wrong? Am I thinking? That's okay. I'll just do 0. I'm thinking of C++, aren't I? So I got to call it mapper 1. Mapper 1. Clear data. Mapper 1. Okay, this is going to be useless now. We'll making a function to draw it. Okay, this is fine. I just want to see how much memory I'm using. Oh, it's jumped up very, very high. Guess that's from bringing all these libraries here. Okay. I kind of want to. Yeah, I'm pretty curious actually. So let me just get rid of all. I'll just undo it quickly. So here, here, here. I think that's it. Yeah. Now about the SPI library. not to. Nothing, because it's already a standard library. So it's probably done. Ignore what I'm saying again. Okay, so this is okay. So we have we're in the class, so we can use map data directly. So this is actually useless for now. Actually, I'll even put it to the side. I was going to draw it in the main function, but don't need that anymore. Okay, so from our load to high value, so we're going to have two temporary values, or I could do this. No, I'd have to calculate it twice. So it's speed versus pace. You'll know what I'm talking about in a second. Temp 1, temp 2, temp 1. Yeah, okay. So int, we have a temporary value. We're going to take our map data function and we're going to map it first. So map magnitude and degrees. So something with a magnitude of 3, 45 degrees, or 2, I got to remember my trigonometry again, jeez. Alright, let me do this off memory if I can. And this is 2. Sine is to find the ratio. Inverse sine is to find the angle. I want to find the ratio between this and this. So the hypotenuse is the right angle. That's the hypotenuse. Here's the opposite. Here's the adjacent. Right, these, right. Don't make me use Google for this. Right. SOHCAHTOA, obviously. Opposite over hypotenuse. I use sine. And yeah, this is exactly what I'm talking about. 2 sine 45. Okay, so sine 45. Right. Wrong. It's 180, that's 90, that's 45. I think it's something like 0.7 or 7, or am I thinking of something else? Let me see the calculator. No, that's okay. And then 2 times sine 45. 2 times. No. Okay. Root 2. Okay, why was I thinking of this? Yes, because we're scaling the polar form and not the Cartesian form. So it's actually going to be a bit skewed. It's going to be bigger here, then it's going to skew. we should, let me just show you, because in the previous function I mapped it first, then I converted it into the Cartesian form, but now I'm thinking we should convert it first, then we map it. Which is probably yeah, I'm going to try it that way now. I'm going to convert it to that and then map it. Yeah, okay. So let's have our x coordinate, our x1, because we're drawn between 2 points. We're not drawn between 1 point. Int x2. I'm not going to do this in one line, so int y1, int y2. And I'm just going to copy and paste this because no, I'm not going to do copy and paste the first one. So we'll take the map data. So here's our magnitude. What amplitude? It's not the magnitude because you can have negative. So and then we multiply it by cosine of the degrees. But that's the sit down. Yeah, okay, never mind. Cosine I, and this is actually not in the right form, so we multiply it by pi. Pi is not defined, I don't think. So 3.14159 divided by 180. This is accurate enough. And we're just gonna typecast this. Just in case, because this would actually return a float. I'm not sure if it actually would, but yeah, it probably would. So we're just going to copy and paste this for the y value. No, wrong one. The y value, we just take the sign. Okay, so this gives us our first point, and now I'm going to get the second point. One more thing. If we're going from left to right and it ends up displaying it right to left, so we're going in polar form, we want to start from left to right, I think. It depends what way you mount your server, I guess. If you do it upside down, it won't matter. For now, I'm not doing it upside down, so... No, I am doing it upside down. So we start from this degree. You know what? I'm gonna... Okay, I'll put this in brackets just in case. It'll be ready. And again... Oh, I guess it's good. I did that. Gonna get our second point. And I'll just copy and paste this one instead. Just change out signs. So we've got our 2 points to draw. Yes. And I could have mapped. Don't want to complicate this. complicate it, whatever. So we're going to map this value. This is probably not good practice, but oh well. So be ready. No, I'm doing this very slow today. Okay, so we'll map this. The range of these values is going to be, I guess you do get 0 sometimes. So 0 and 400, since that was our max. So actually, max range cm max centimeters as 400. Right, so we're going to map out x and even our y is actually. No. Yeah, no, we have to uniformly scale it, so between 1 maybe, so yeah, it's not going to make a difference unless you do, okay, 0, and our screen, what? Yeah, I think that's the best way of doing it. Maybe. I'm going to test this, see if this works. This is the first thing I'm really unsure about. I mean, as far as the code working or not. Also, I'm that unsure, I want to check for errors. No, I didn't call it screen width. Okay. That's annoying, but hell. I guess I should capitalize definitions. No, I should capitalize definitions. Alright, all good. So this is mapped. Now do I want to further complicate this or do it on a new line? I don't want to keep the lines as short as possible when rereading this, so x offset and y offset. Yes. No, that will really complicate it. See, I'm thinking of how we can put the map anywhere on the screen now and we can scale it to any size, but I'm not going to do that right now, but I got a good idea how to do it. And this video is getting very long, nearly 1.5 hours. But this is my first ever tutorial slash not actually tutorial video, and people in 1 hour have done a lot more than this. This is very slow. So okay, I'm just gonna draw it now. Well, after see, I want to do it in on this. No. So I'm just gonna put it on the offset. What I'm doing. So x1 equals screen bit more efficient. Since I'm doing the screen in portrait mode, you could have a function. Again, you probably don't know what's going on in my head right now. If you do, congratulations. If portrait, whatever, I'm not gonna actually, okay, yeah. If portrait, come on. Good enough. Alright, equals true. I use screen width, else use screen height. And then you have to not going to do that for now. So I'm just, since I will explain this. So since our coordinates, our polar coordinates from here to here got translated into the Cartesian coordinates, and this is 0, this is positive infinity, x, this is y, this counts up. Now here's our x, this counts up, and this counts up. So what's going to happen? We're going to get our first point here, and we have our obstacle. Oh, we're off the screen now, I don't know what it's going to do. I haven't even tested it. So this is how it's going to go. It's going to go from here at this point. So this is this line here is this line here. And when you get to the other side, there's no screen here. Because x is this way, it counts to the right, as you'd expect, but y on the screen counts down. The vertical axis, vertical pixels. So firstly, I'm shifting this, I'm shifting it to here to get the full range here. And this is limited, that's why the mapping was done, to decrease the range so it fits on the whole screen. And now I forgot to, and now we're going to actually use our distance, centimeters, not our max range. This scales the, the resolution of the map in a way. That's okay. So x1, x2. Now since we're counting down, we want the map to go this way, not this way. So if you go y, you start at position, and then you're plus y, you don't want to go this way, you want to minus from the value, your position. If that makes sense. So I just copy, paste, y1. I mean, this will work, but it's going to be drawn down instead of up from the central point, so we'll minus it instead. Again, plus equal will work fine, but this is a better way of doing it. I actually want to turn your screen upside down. Then you'll have to invert your text, you'll have to rotate your text 180 degrees as well. Okay, I think I'm going to test it with the inverse off and not write this yet, because this video is getting a bit too long now. So this is fine, we have all our points. Now that's it, we can draw our line. And later on I'll just do the function, we could choose our colour in the function as well. For now, it'll stay like this. So let's draw a line, that's all that's left, and that's it, this should be complete. If it's done correctly, which we'll have to test in very shortly. So draw from x1 to y1 to x2 to y2, pick a colour. Let me think of a colour while I do this. Black, background, I guess green. I mean, I did green before, but I do like the green. Or maybe a different one. I do like the green. Yes. Okay, time to test. No, what did I do wrong? But hang on, let me just. Sometimes I just like to do a few undos, see what I changed. I see the problem. Sometimes I should probably learn to read these error messages a bit better. Yes, okay. Now I'm going to compile it and see what happens. Okay, so it's working pretty well now. As you can see, it's jumping back and forth because I'm not keeping it entirely still. I'm not keeping it against flat sensors. There are limitations to using this particular rangefinder to map the room. If I keep it still against, just let the motor's pin point up at the ceiling, which isn't actually too far from me since it's slanted. The last part should be, yeah, nice. That's when I turned it over, this final part. Now I'm going to point out a few mistakes I made. Okay, let me unplug this. So I'm just deciding to do it like this. Yes, firstly I did plus equals, minus equals, minus equals. I'm not actually subtracting from this itself, I'm subtracting from the width of the screen. So this is the correct way of doing this. I forgot to actually call the function to draw a data range. I chose 150 as the max it would show. Obviously you can play around with that. The exit was I left the definition, the type definition in there, and I made it equals 0, so this should be the while loop. I think that's all for the problems. Yeah, that should be fine. Just a few problems. I was lucky I got away with so little at all, to be honest. Anyway, that's all for now.